Hi all, in today's video we'll be discussing about framing in computer networks. Framing is a fundamental concept in computer networks, providing a structured way to transmit data between devices. Data is organized into discrete units called frames, facilitating efficient communication across different networks and protocols. Introduction to frames. Frames are the basic unit of data transmission in a network. They contain a header, data payload, and a trailer, providing essential information for routing and error checking. Structured data. Frames ensure data is organized for transmission and reception. Error detection. Error detection mechanisms in frames help identify and correct corrupted data. Addressing. Frame addresses allow for routing data between specific devices. Protocol specificity. Different network protocols have their own frame formats and conventions. Frame structure and components. Frames consist of distinct parts, each serving a specific purpose. Understanding these components is crucial for efficient data communication. Header contains metadata such as source and destination addresses, frame type, and other control information. Data payload carries the actual data being transmitted, including text, images, or other types of information. Trailer includes error detection codes and other information for verifying data integrity and signaling frame completion. Framing protocols, Ethernet, Wi-Fi, and beyond. Various network technologies utilize specific framing protocols, each with its own characteristics and requirements. Protocol Ethernet, frame size 1500 bytes and error detection is CRC. Protocol Wi-Fi, frame size 2312 bytes and error detection CRC. Protocol Token Ring, frame size 4500 bytes and error detection FCS. Framing and data link layer. Framing plays a critical role within the data link layer of the OSI model, responsible for reliable data transfer over physical media. Physical layer transmits raw bits over the physical medium. Data link layer organizes data into frames, manages access to the physical medium, and provides error control. Network layer provides logical addressing and routing of data across networks. Error detection and correction in frames. Error detection techniques are essential to ensure data integrity during transmission. Framing protocols use methods like checksums and cyclic redundancy codes to identify corrupted frames. Checksums. Simple calculation based on the data payload used for basic error detection. Cyclic redundancy codes. More robust error detection mechanism capable of detecting multiple errors. FEC, forward error correction, allows for correction of errors within the frame without retransmission. Frame addressing and identification. Frame addressing ensures that data reaches the correct recipient within the network. Frames contain unique source and destination addressing for routing. MAC addresses, physical addresses associated with network interfaces. Logical addresses, used for routing between networks and devices. Fragmentation and reassembly of frames. Large frames are sometimes fragmented into smaller pieces for efficient transmission over networks with limitations on maximum frame size. Fragmentation, breaking down a large frame into smaller fragments. Transmission. transmitting the fragments individually over the network. Reassembly, reassembling the fragments at the destination to form the original frame. Real-world framing challenges. Real-world network environments present various challenges to framing, including noise, interface, and network congestion. Interference. External signals can corrupt data during transmission. Congestion. Heavy network traffic can lead to delays and packet loss. Thank you.